Hello everyone, welcome to our second part of the last project in our Introduction to CFD course. This time around we'll be doing the mesh for the geometry that we created in the last class. Alright? So to do this class you will need to have the geometry from the previous class. All right, you cannot do this class without it. All right, so without further ado, this is what you're gonna do. The thing that I'm doing here, you don't need to do, because I'm doing this so I have a mesh that is starting from scratch, starting from zero. Okay, it doesn't have anything, right? And since I like to do the problem that we will be working on in the class beforehand, I have already done it here. And if I open this up, it will start from the point where I left it. And even if I reset the data, some features that I added will still be there. Okay, so this thing that I did here, you don't need to do. This is things that I'm doing here. All you need to do is right click mesh and click edit. All right, this is everything you need to do. And in the mesh generation process, what I want you guys to really pay attention is, especially when we are generating the mesh, after we added all the functions and the methods, there is a very specific order that you need to follow so you generate the mesh properly, accordingly. Okay? If you change the order, you will change the mesh as well. Okay? So I need you guys to pay attention to the order that we'll be doing our mesh generation, okay? Other thing that you need to make sure you have, and this is something that I added something that I talked about in the previous lesson, is you will have these regions here. You can see that our geometry is all sliced up, okay? Most of these slices, I done them so the mesh generation process could be a little bit smoother, a little bit better, and a little bit more, let's say, didactic. Okay, so you guys understood it better. All right. So let's begin. First, the thing that we need to do. Actually, first I'm going to generate the mesh using the default configurations of the mesh generation. Okay, so this is the mesh. You can see that in some regions we have this tetrahedric mesh that is very, let's say, organized in these regions here, and you can see that in the inlet pipe, let me turn around. You can see that is also very organized in the inlet pipe. Also very organized in the island region. This is going to be the region that we will represent our vegetation, if you remember. Okay, this rectangle right here. Okay, so if you take a look at the other regions, however, they are using a different type of element. Okay, and although there's nothing wrong with using this element, when you combine these connecting regions right here, they're not properly done. Okay, they are not very well organized to each other, and the transition from this region to this one will not be the best as possible. Okay, we can do better than this. So basically what we will do is make all the regions of our channel something more similar to these regions right here. Okay, and something that you can also see is the number of nodes and elements. Okay, nodes is the points that connect each element. Okay, and the elements are these little rectangles here, these little triangles, all right? They are the elements, and the volumes are the points connecting them, okay? For example, this is one node, this is another node, this is another node, okay? So we have a little bit over 11,000 nodes and a little bit over 3,000 elements, okay? This is for you to see what the mesh will look like if we only came in the mesh generator and select, okay, generate a mesh for me, all right? Now let's start generating our mesh, okay? So if you did this in your workbench, all you need to do to erase this mesh is right click the mesh and go to clear generated data. You can accept, so it will go back to the starting point, okay? Now let's begin. The first thing that we're gonna change is our physics preference. We're not working with mechanical problems, we are working with CFD problems, okay? So this is the first thing that we change here. I'm not gonna go into a lot of details about every single change that we do, because otherwise this class would be too big, and like I said in previous lessons, everything there is to know about mesh would warrant a course of its own, okay? Mesh can be very complicated, but if you are able to do a good mesh, you will save a lot of time, because a good mesh is not a mesh that has a lot of elements, that has a lot of nodes. It's a very well organized mesh where you refine it in the regions that you are most concerned about, okay? So we change the physics preference. This will change how the elements are created, and how they are inserted in in our geometry, okay? Let me show you. I only changed the physics preference, and the solver preference, it was from Fluent. I changed it to CFX because this is the package that we are using, okay? Now let's create a mesh. See? It changed a little bit here. If you remember correctly, there were like, I think 3 lines of elements here. Now there's only 2 near the wall. Okay, near the wall there were 3, now there's none. But here is a little bit better because the CFD can work a little bit better with this type of elements. And you can also see that in the inlet region, the elements there are way more elements and they are better organized. Okay, so you can already tell a little bit of the difference between you leaving the physics preference in the mechanical option and changing it to the CFD CFX option. All right, but this is not enough. And you can also see here, you can see that the number of elements have increased. Before we had a little bit over 11,000, now we have a little bit over 15,000. And the elements as well, we have now a little bit over 22,000. Okay? But this is not enough. So let's clear this data. Oh, I don't think I mentioned it, how to create the mesh. All you need to do is clear generated data. You can come here and you can select generate mesh. Okay? And it will create the mesh. But let's give this mesh a little bit more of our insight, okay? A little bit more of our touch, okay? So what we're gonna change here is in the element order, we're gonna change from linear to program controlled, and the element size we're gonna do 0.25. Just make sure, for some reason, sometimes in the meshing package, or even the geometry generation package, instead of using point, the software is using comma, okay? So for example, if I put 0.25, it will give me this error, and it will say, okay, you put something that I cannot read, so I'm gonna change it for you. All right, and you can see that it changes to 25. Okay, so check if you need to use comma or if you need to use point. All right, very well, let's continue. Now what you're gonna do is you're gonna expand the sizing. I'm gonna even get me some more space here. So we're gonna expand the sizing by clicking the plus button. Okay, and now what you're gonna change here is you're gonna enable capture proximity. This will give us a little bit better mesh in the regions that are close to each other. Okay, for example, here in this region, in this region, in this region right here, in this little triangle. Okay, so make sure you enable this option. Now what you're gonna change, you can collapse sizing and expand quality, and you're gonna change smoothing to high. Smoothing is something that happens when the mesh is being generated, and especially in the connection regions as well. Okay, so you increase the smoothing so you have a more smooth transition from region to region, or from elements to elements. Okay, this being done, what we're gonna do now is we're gonna start inserting our mesh methods. Okay, so how you do this? You go to you right click mesh, you go to insert, and you select method. Okay, and you have this method right there that is asking you to select a geometry. And how you do this is you left click here. If you have anything other than the body selector in your mouse pointer, all you need to do is go here, click body, or you can type Control B. Okay, and you can already see that it has changed, right? So now I'm able to select the inlet pipe. All right, and you can click apply. The method that we're gonna use is not gonna be the automatic, it's gonna be the sweep method. Sweep method is a very good meshing generation method because it generates very organized meshes. The problem is that it needs to for it to work, you need to select two faces. And the faces that you select, they need to be very similar to each other. Okay, for example, I cannot use a sweep method in this region right here, because if I select, for example, this face, the back face is very, very different from the front face, which is this one right here. Okay, so the sweep map will not work. You will not even be able to use it because the software will say to you, oh, this body that you selected is not sweepable. Okay, but this one is. So we're gonna use it there. Anytime that you are able to use the sweep method would be wise to use it, because it generates very high quality mesh at a very low computational cost. Okay, so with this body selected, with this geometry selected, what you will change is the screen target selection. Instead of automatic, we're gonna use manual source. So what this means is that we are selecting the origin point of the sweep method. Okay, so if you selected body to be your sweep geometry, the source needs to be a face. It needs to be, how can I put this, one level in the hierarchy lower. Okay, so if it's a body, if it's a volume, you will select a surface. If it's a surface, you will select an edge, for example. All right, So to select the source, you left click here and you select this face right there, this face right here. Okay, if you don't have this the face selector in your mouse pointer, all you need to do is go here and select face and you'll be able to select it. Okay, so make sure that this face is highlighted in green and you can click apply. All right, now we're gonna do the same thing for the outlet pipe. All right, so what you can do, you can select zoom to fit, or you can type F7 and it will zoom to fit the entire geometry no matter where it is. Okay, now I'm gonna change so I can better see the inlet pipe right here. For you to do this, all you need to do is use your mouse wheel pointer. Okay, you click the mouse wheel and you can click and drag so you change the geometry. If you don't have a mouse wheel on your mouse, all you need to do is you can go and select rotate and you will do the same thing with your left click, right? So what we're gonna do is we're gonna insert another method. We're gonna select the outlet pipe, and the method is also going to be the sweep one because we can use the sweep method here. Okay, again, we're gonna change the screen target selection from automatic to manual source, and we're gonna select this face right here. Okay, and you can click apply. All right, so it's a very similar method to the inlet pipe. It's basically the same. All you need to change, you need to make sure you are selecting the correct bodies and the correct faces. Okay, very well. Now let's move on. Well, now what we're gonna insert here is sizing. Okay, because we wanna tell the software to use a very specific sizing method to one of our regions. Okay, if you don't do this, he's going to use the ones that are selected here in the default mesh creation. Okay, so we're gonna insert a sizing. We're gonna select the geometry. The geometry that we're gonna select is again the outlet pipe. All right, and we're going to use the element size and we're going to change it. You can see that it's using the one that we previously selected, but we want a finer one for this region. Okay, so we're going to change it from 0.25 to 0.025. Okay, so it's 10 times smaller. All right, what you need to change here, you also need to enable capture curvature. All right, okay, now let's create our third method. Okay, we created two sweep methods and a body sizing. A body sizing is not a method, a meshing method. Okay, but we're gonna create a third one, and now we're gonna select the remaining bodies of our geometry, except the one that we will use to represent the vegetation. So what you need to do is you need to hold Control and you will select all of these bodies right here. Okay, and you need to click apply. Make sure that you have 10 bodies selected. Okay, you have all of the bodies selected except the inlet pipe, the outlet pipe, and the rectangle that we're gonna use to represent our geometry, our vegetation, sorry, right? So with this bodies selected, you change the method from automatic to hex dominant. All right, very well. Now we will create our fourth and final method that is the one that we use to represent the vegetation. For the vegetation, we're also going to use the sweep method, all right? For the vegetation, you don't need to use the screen target because the faces are exactly the same, so he will use either of them will be fine, all right? But we are also going to improve some stuff in this geometry, in this mesh for this geometry. Let me give you an example. I'm going to generate the mesh only in this body right here. So I'm going to select it, I'm going to right click it, and I'm going to select this one, generate mesh on selected body. So he will only generate the mesh in the bodies that I selected. In this case, the green rectangle. Okay, there it is, our mesh. So if you click here, we can see that is a very well organized mesh, but it only has 1, 2, 3, 4 elements in our vertical axis right here. This is not enough. Okay, we need to have more elements here so we have a better mesh. So what we're gonna do is we're gonna clear this data, okay, and we're gonna give the program some information so he can generate more elements in the vertical region here. All right, how we do this? We go to insert, we insert sizing, and now what we're going to select in the sizing is the edges of this rectangle. All right, so how we do this? You go here and you select the edge command, all right, and you will hold Control and you select that edge, this one, the one in the back, and this one. So you can see that I selected the 4 edges of our rectangle that will represent the vegetation. Okay, and you can click apply and you can see that we have selected 4 edges, and you can see how many elements is being generated here. You can see that 1, 2, 3, 4, 5 will generate 4 elements, okay, because it's using the default element size from the mesh. But we're not going to use this one. We want more elements, okay? So we change the type from element size to number of divisions, and we want 10 divisions. You can already see that it changed from 5 to 10 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. All right? We're also going to change the capture curvature from no to yes. Okay, and let me show you now how different this mesh will look like. And you can already see that it takes a little bit longer because it's a more refined mesh. And there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements now in our vertical region instead of only 4. All right, remember that these functions that you use will be dictated by the critical regions of your problem. Okay, so the critical regions for our problem here are the inlet and the outlet pipe, because they are regions that will have a very high velocity gradient, and also the vegetation, because if we're studying vegetation, which is what our example will study here, this region needs to be very well defined. All right, and furthermore, this region also has a very high velocity gradient because it's going to be a porous region when we set it up in the CFX Pre. Okay, so it will have very different velocities inside of it, especially in the regions contacting the outer channel. All right, but now let's clear this data. Okay, so Right now we have everything that we need to generate our mesh, except that we also want to create the names for our faces that we will use in the CFX pre. Remember, if we create these names here, our work will be cut in the CFX pre process. Okay, so that's what we will do now. Let's create our named faces. All right, how you do this? Well, you select face first, the face selector, and then let's create first our inlets. So we have the face selector there, we click on our inlet face, we right click it, and we go to create named selection, or you can simply type N. All right, and now we need to name this properly. We will name this inlet. There we go, that's all we need to do. I'm going to erase this symmetry that it was already generated there, because I want to create all of them. All right, so I created the inlet name selection. Now let's create the outlet named selection. We select this face, right click it, go to create named selection, or we simply type N, and this one we will name outlet. All right, very well. Now we will create the symmetry faces. We will have here in this geometry, we're gonna have two domains when we set it up in CFX pre. So I will create two symmetry faces, two symmetry named faces, one for each domain. Okay, so the first one is gonna be the symmetry for the channel, which is gonna be all of these faces right here. So you you hold Control, and you select all of the top faces from these 10 bodies right here. And then you right click it, create name selection, and I'm gonna name it symmetry. All right, and I'm gonna do the same, but for the top face of the vegetation. So we select it, right click it, and I'm gonna name it symmetry _1. Okay, and now I'm gonna create the domain that will represent the vegetation. So I'm gonna select the body, since it's a domain and we're dealing with a 3D geometry. The domain will probably be a volume, it will probably be a 3D geometry as well. So I'm gonna use the body selector to select the vegetation geometry. I'm gonna right click it, I'm gonna do the same, create image selection, and I'm gonna name it FTW, which is an abbreviation for floating treatment wetland. Okay, and you can do this, and you can type OK. Actually, I'm gonna name this FTW _1, because when we advancing this final task, final project, you will need to have more than one of these. Okay, so this creates a better habit, so to speak. Now we're going to generate the mesh, but like I said before, we need to generate this mesh in the proper order. And what is the order? The order goes from the regions of interest and the critical regions to the lesser ones. All right, so in our geometry here, the critical regions are the inlets and outlet pipes, and the interest region is the vegetation. Okay, so these are the regions that will need to come first and will dictate the order of our geometry, of our mesh generation, right? So what you will do here is you will hold Control, you will select the inlet pipe, you will select the vegetation, and you will select the outlet pipe. All right, And then what you will do is you right click. You can right click anywhere on the screen and you will click generate mesh on selected bodies. Okay, and now you can see right here that is generating the mesh. So there you go. We have generated the mesh for our vegetation, and as also we have generated the mesh for our inlet pipe and for our outlet pipe. And you can see that it's very well organized with a lot of elements. Okay, you can already see that only for these 3 bodies we already have more nodes and more elements that we have for the entire geometry in the default mesh generation. Okay, now let's continue. Now, which geometry we will use? We will use the ones that are closer to our interest regions and our critical regions. So we're gonna generate mesh for this geometry right here that is in closest contact with the vegetation, and it also has the more surface area contact with this region more than this one and more than this one. So this is why we generate the mesh for this one first. Okay, the time that it takes to generate the mesh will vary from computer to computer as well. All right, so there you go. We have generated the mesh for this geometry, and you can already see the difference. Remember, the default one have these very large rectangles, very large cubes in this region. Now you can see that it's much closer to the ones that we find here. Okay, and this region is different because it's the contact region, so it's making an effort to fit almost like a puzzle piece in the zone that was generated before. This is why the order is important, because let's say we generated this body first and then this one. What would happen is that the mesh for this one would make an effort to fit the mesh that was already created in this body. This is why we need to create the points of the bodies of interest first and make everything else fit to them, not the other way around. All right, now that we created this one, we will create the ones that are connected to the inlet and outlet pipes. All right, generating. Almost done. And you can imagine why this is taking longer than this one, because it is in contact with a region that the geometry is very different from them, right? Here you can see that we are dealing with, like, if we cut all this geometry, we would have what? A triangle and a rectangle maybe, which is easier to fit in another rectangle than a circle is, than a pipe is. All right, this is why this takes longer to create. Okay, now that we have done these regions, we're gonna do these 2 right here, because they are both of them are regions that are in contact with the vegetation and that are in contact with the inlet region that we just created. Okay, so we're gonna generate these ones right here, and then we're gonna generate the one for this part, the mesh for this part. All right, so you can see that for any geometry that we generated relative to this problem, we would follow a similar order to this one. We would generate the inlet, outlet, and vegetation mesh, Then we would generate the one that has the higher contact surface for the vegetation, then the higher contact surface with the inlet and outlet pipes, and then so on and so forth. And you can see that it's a very well organized mesh. Okay, now we will generate the mesh for this part, for this body. Okay, there you go. This thing that is showing right here is that he's telling you, look, you're selecting the order that you're creating the mesh, but you're not recording it. One other function that you could use here is there is a record function. And if you click to record and you start generating the mesh in the order that you want, if you want to do it again, let's say, oh, I changed something, I changed my meshing element size, but I want to maintain the order. All you need to do is we would need to play your recording, and it would generate the mesh in the corresponding order that you created. But to create a muscle memory, so to speak, I want you guys to generate the mesh every time following the correct order, okay? And now we're gonna generate the mesh for our 4 remaining bodies, okay? And you can generate the mesh. There you go. Now our beautiful, well-organized mesh is complete. I encourage you to go back and see how the default one looked like and compare to this one, okay? And we ended up with 634,000 nodes and 165,000 elements, which are more aligned to what we would expect from a 3D geometry of this size, okay? The amount of nodes and elements we had before were way too little, way too small for a geometry that is 3D and of this size, okay? So, with your mesh being done, you can close the mesh generator, you can save your project, and what you guys will send me is this thing right here. Let me delete this. You have something like this, okay? And how are you gonna send me the file? You're gonna go here, you're gonna click archive. Yes, you can save it, and you can name it anything. That's no problem. You will save it, and you will send me this file that you created, which will be around 23 MB, which I believe Gmail allows up to 25, right? So you can send me this file right here so I can take a look at your mesh, and also I will be able to take a look at your geometry that you did previously, right? So this is it for this lesson. If you guys have any questions, let me know via email, and I'll see you guys next week for the setup for our final project. I will probably do it in Portuguese because there is a lot to cover for the setup, but nothing. Yeah, I might do it in Portuguese so it's easier for you guys to understand. All right, so see you guys next week and take care.